I knew that if we were going to tell the story of the origin of dinosaurs, we had to come here.
You can look at his jaws and imagine the great gulps of flesh it could have taken from the thigh of Desmatasuchus, whatever.
What's striking about the fossils we find here is the incredible low diversity of species.
And I thought to myself, something's here.
And Bob picked up a little dentary with teeth in it, and he looked at it, and his mouth fell open, and he said, "You're right, Jack, this is a baby dinosaur."
The Dinosaurs is made possible by the Corporation for Public Broadcasting and the financial support of viewers like you.
Only a handful of bones belonging to the earliest dinosaurs have ever been found, and they came from here, a desolate valley in northwestern Argentina in the foothills of the Andes Mountains. If more bones existed, this would be the place to look, where wind and rain have exposed Triassic rocks that are 230 million years old. In 1988, Paul Sereno, a young paleontologist from the University of Chicago, came here along with his Argentine colleagues.
I'm sitting at the top of the Ischugalasto Formation. In these pale badlands that stretch behind me, we find the first remains of dinosaurs. In the slightly younger red rocks that tower behind me, we find the beginnings of the great diversity of dinosaurs that were later to take over the entire surface of the Earth.
Over 30 years ago, in 1959, a few shards of bone had been scraped out of the Earth, but since then, no scientist had found anything of significance. And yet, Paul Sereno had a hunch.
I knew that if we were going to tell the story of the origin of dinosaurs, we had to come here. But after 3 weeks of hard work, we hadn't found the specimen which would do the job.
Then one day we went to this little area of badlands that we hadn't been to yet. It had been kind of hidden behind the other areas.
And so I came down here with a group, but I was here first, and I came down, put my backpack on a ledge there, walked up this gully, about 25 feet, 30 feet. The first fossil I found was right on this mound here. And I naturally, not wanting to be disappointed, didn't think that I wanted to think it was everything but an Ararosaur skeleton, but as it turned out, I saw what looked like to be neck bones, and I followed one to the next, and there was the back of the skull. And it couldn't be anything but a primitive dinosaur, and I was overwhelmed. I just couldn't believe what I was looking at. I sort of would look somewhere else and then look back down at it. As people gathered around, the crew gathered around, I walked away because I couldn't look at it anymore, and I came back, and there was just a tide of emotion. I wept.
Paul and I just gave each other a big bear hug, and we were jumping up and down and yelling, and everybody else came over by then. And it was extremely exciting. This is what we wanted.
Sereno had found an almost complete skeleton, including the skull, of the earliest known dinosaur, called Herrerasaurus.
This is the wonderful skull of Herrerasaurus that we found back in the valley there. The nose is at this end. The first thing that's easy to see with a skull like this is that Herrerasaurus was a carnivore. It was a flesh-eating animal with these long, recurved teeth for slicing through flesh. But it's not just any kind of carnivore. It's a specialized kind of carnivore. And one of the best evidences for that is this unusual and interesting sliding mechanism that we find in the lower jaw. This hinge in the middle of the lower jaw allowed the front part of the lower jaw, which had the teeth, to flex around a struggling prey.
But Herrerasaurus faced some stiff competition in the Triassic Age.
The most important thing that we've learned from our finds of Herrerasaurus is that we have gained, finally, the first complete picture of what an early dinosaur looked like. And this picture will help us understand the subsequent diversity and radiation of dinosaurs that occurred over the next 150 million years.
The rocks of the Triassic period date back 250 million years. The dinosaurs found buried in those rocks were newcomers to the evolutionary sweepstakes, fighting for survival with older and more established creatures who were well-armed and superbly adapted to their environment. They shared their world with other reptiles and with primitive mammals. In the oceans, dolphin-like fish lizards feasted on other sea organisms and each other. Traces of this Triassic world can be found here, hidden in the rocks of the petrified forest in Arizona.
This region is called Wizard Wash, and you can sort of see why.
Paleontologist Rob Long.
The sandstone has been eroded, it's been weathered into these great creations. You can see goblins here, you can see dragons, but it was very different 220 million years ago.
Long imagines the Triassic landscape like this: lush, wet areas, lakes and swamps, vast forests with myriad varieties of trees, some 120 to 150 feet high, and dominated by reptiles, including those who were doomed to extinction as dinosaurs gradually took over. Such a one was a harmless plant eater, Desmatasuchus.
This is Desmatasuchus. Probably weighed about 1,000 pounds. He was one of the largest of the herbivores or plant eaters in the petrified forest. You can see he's rather peculiar looking. He has this funny looking snout, like a pig snout, with reason. He was a grubber. He'd stick his snout in the ooze, the mud, and pull out roots, bulbs, whatever. And you can see his teeth along here, peg-like, typical of a plant eater. But the most remarkable thing about this creature is its armor. You can see you get a series of great horns over the neck, and they develop into these almost Texas longhorn type spikes over the shoulders. Not only was the neck completely covered with armor, but all along the back you've got these rectangular plates, you've got these knobby, sort of horny plates, continuing all the way down to the tip of the tail. The underside of the animal was covered with plates. Even the limb elements were all covered with this armor. And there was a very good reason why this animal was so protected. This is Postasuchus, another thegodont, But unlike Desmatosuchus, you can see it has these great recurved daggers serrated on the edges, sort of like Tyrannosaurus teeth for cutting through flesh. But you have to remember, this animal is 3 times as old as Tyrannosaurus rex. You can look at its jaws and imagine the great gulps of flesh it could have taken from the thigh of Desmatosuchus, whatever. Here we have 16 feet of animal. This is a mid-sized Postosuchus, probably weighed about 600 or 700 pounds. Much larger than any of the meat-eating dinosaurs of its time. You can see a very long tail, sort of counterbalancing this big, heavy, deep head. Postosuchus has done certain things. He's tried to be a dinosaur, but he hasn't been able to be one. The hind legs are very long. The forelimbs are very small. The hind legs have become directly underneath the body, very vertical, almost bird-like posture. He was an early experiment that failed.
Why did Postosuchus and his like fail? Doctors Neil Shubin of the University of Pennsylvania and Hans Sues of the Smithsonian Institution have come here to the Smithsonian's laboratories to find out how the first dinosaurs managed to beat out their competition. It's a puzzle. How could the relatively small upstarts of the Triassic period shoulder aside creatures as formidable as Postosuchus? A block of stone in the institution's research area contains a butcher shop of shoulders, shanks, thigh bones, and jaws, most of them belonging to a diminutive early meat-eating dinosaur called Coelophysis.
Probably the rest of these animals, and they're still...
This is one of the smaller specimens in the block?
Yes, definitely. They get considerably larger than that.
So how many specimens are in this big block here?
Oh, a dozen or so partial and complete skeletons, and there are probably going to be at least as many more as that.
And you have a problem like figuring out which bones go with which, I mean.
Yeah, exactly.
And in the little block, there are at least 3 specimens, right? I mean.
Yeah, here's a large individual. These are his hip bones here. We've already removed most of his leg bones, but there's his tail coming back toward me. And over here we have another individual with his leg folded up. There's his pelvis, his thigh bone, his lower leg, and his foot underneath here with toe bones coming down here with nice long claws on them. And in between is a little baby's skull. Here's his nose, and there's his teeth with his mouth is tightly closed. And we can even see some of the plates around his eye that are preserved in his orbit here. The skull's crushed, but it's in really good shape. You can see all the bones in his palate are preserved in here.
There are a lot of reptiles running around in the late Triassic. What Coelophysis and the dinosaurs share is a stance which implies that they were very agile terrestrial animals. This stance involved moving the legs underneath the body, and in effect a bipedal posture. So that involves, adaptations of the leg and of the foot. In fact, some people have implied that this stance and then the ability to be a very sort of agile terrestrial organism enabled dinosaurs to take over the earth, to be dominant forms over all the other archaic creatures that were around at the same time.
Shubin's theory that early dinosaurs became faster on their feet than their Triassic relatives could explain some of their success, but was something else needed. As the Triassic period gave way to the Jurassic about 200 million years ago, there is evidence of what scientists call an extinction event. It appears that at every stage of evolution, changes in the ecosystem, catastrophic to some creatures, provide an opportunity for others. This is what may have happened with the dinosaurs. What caused the extinction event? We don't know. It could have been a meteorite or a volcanic eruption or disease. But whatever it was, it had a profound effect on life forms all over the world.
Here we are on the shores of the Bay of Fundy, and in these rocks is contained...
Neil Shubin is testing his lungs as well as his theories as he flies to the Bay of Fundy in Nova Scotia. The rocks here contain evidence of one of the largest extinction events of all time. On these cliffs, the Triassic-Jurassic boundary is visible as a white line. Below the line are rocks from the Triassic period, containing the remains of creatures from 250 million years ago. Above it are rocks from the Jurassic, containing younger animals, including dinosaurs. Hans Seuss, Neil Shubin, and their colleagues are excavating right on the Triassic-Jurassic boundary, where the cliffs contain a record from 200 million years ago, the early Jurassic period, when dinosaurs got their opportunity and seized it.
That's like it's like a flat plate.
Yeah.
Right now, they're examining Jurassic fossils.
I mean, altogether, what's striking about the fossils we find here is the incredible low diversity of species. And if you compare that to the late Triassic, you have an incredibly high number of species. In fact, the only difference between these set of rocks in the Jurassic and those in the Triassic are that these are lacking typical Triassic elements. In fact, they're lacking many species. So in essence, what we're looking at is a day after fauna, a fauna that has survived a large extinction event, and dinosaurs were among them. Another Sphenodon.
The day after population Shubin is referring to consists of small mobile creatures, the first true dinosaurs. Some of them were fleet-footed predators, hunting down small lizards and mammal-like reptiles, chopping into them with teeth shaped like the blades of a steak knife. Others were small plant eaters. Their larger competitors had been mysteriously but irrevocably eliminated. The field was open. The stage was set for the monsters that were to come. They started in a modest way, some no larger than chickens. Allowed to range free and evolve into more and more efficient forms, these new, more advanced beasts grew and grew, larger, stronger, taller. They developed serpentine, ribbon-like necks, tails like tree trunks. They became, in short, the dinosaurs we think of when we hear the word, the colossal beasts that haunt our fantasies. All the largest of the Jurassic dinosaurs, Brontosaurus, Brachiosaurus, were vegetarian, cropping a landscape that was lush with primitive conifers and palm trees, ranging through the forests in a perennial harvest time. Among dinosaurs, plant eaters outnumbered meat eaters 20-1. Much of the vegetation that made up the dinosaurs' diet in the Jurassic period would be familiar to us today. At the Field Museum in Chicago, Peter Crane.
Most of the plants that you see growing here behind me are representatives of the sorts of plants that would have been around during the age of dinosaurs, and particularly in the Upper Jurassic. We have ferns growing on the cliff. We have a large cycad growing over here on top of the cliff. Cycads are superficially like palms, but in fact they're a much more ancient group. They have a fossil record which goes back maybe 300 million years. And during the Mesozoic, during the age of dinosaurs, they were an extremely important part of the vegetation, represented by thousands of species and also very abundant.
This superabundant jungle, with its succulent but slow-growing fronds and saplings, was under severe attack. The huge beasts that had evolved during the Jurassic period were relentless and voracious, capable of gulping down entire bushes at a time. Such a one was Brontosaurus. At the University of Wyoming's Geological Museum, paleontologist Robert Bacher.
This is Brontosaurus. Brontosaurus and its kin were the largest plant-eating animals ever to have evolved on land. One of these guys will go 30 tons. That's as heavy as a whole herd of elephants.
And a whole herd of elephants needs a whole lot of plant life to keep it going. How did an animal this big find enough vegetation to keep it fueled? It had a tripod.
You see, Brontosaurus is balanced right at the hips. And Brontosaurus has 3 hind legs. It's got a right hind leg and a left hind leg. And running right down the middle is this magnificently muscled tail, which was just as big around and strong as either hind leg. So it could pivot back up on those 3 hind legs and send that long neck straight up into the foliage. Let's take it up to stage 2, 16 feet. Now what we're doing now, or what I'm doing, pretending my head is the head of a brontosaurus. And simply by raising the neck, I can get my brontosaur feeding apparatus 16 feet. Piece of cake. Let's take it up to the third stage, 34 feet. Now, by tilting up on its tripod arrangement, Brontosaurus can get its head up 28, 30, 32, even 34 feet. And at that height, it could find some greenery even during the worst part of the dry season. And during the wet season, why, it has its pick of the young shoots. And that's the way the age of Brontosaurus went. Feeding from ground level to middle level to top level of every conifer, harvesting the greenery in an incredibly effective way, never equaled, never surpassed. Now with elephants, or Brontosaurus, you've got to push in the front end a lot of plants. That's a formidable task for the chewing apparatus. Well, what do we have here? We've got a nice row of incisors, biting teeth. Now they can crop off the leaves and branches, that's fine. But now we need chewing teeth back here, molars. And one paradox of Brontosaurus, there are no molars. There are no molars in any Brontosaur at all. Well, that's an interesting problem. The solution is 20 feet further aft.
Bob Bacher has a theory about this process. The answer he favors involves the boiler-like guts of the beast, which he believes were adapted to form an ingenious system for pulverizing plant matter.
Here we are in the Brontosaurus guts, and here we'll find the solution to the mystery of the missing molars. You see, right here, in the center of the guts would be a 400-pound gizzard, a muscular part of the stomach for chewing. How do we know Brontosaurus had a gizzard? Well, crocodiles are primitive Brontosaur relatives. Crocs have gizzards. Birds are advanced Brontosaur relatives. Birds have gizzards. And then finally, there are these polished pebbles found inside the fossil rib cages of Brontosaurs. And it was these that functioned like molars to grind the food into a digestible powder.
But dinosaur bones are typically found in rocky places. How do you prove that the stones and the bones are connected? By sound shadows. We're in the excavation quarry for the skeleton of one of the most gargantuan animals ever discovered. Dr. David Gillette and his colleagues are using the latest in high-tech equipment for dinosaur hunters, a seismic gun. As light casts shadows, so does sound. The noise created by the seismic gun creates a shadow of dinosaur bones and other features on microphones lodged underground.
Position, you get ready to shoot.
Then the computer system analyzes these changing patterns of shadows to create an image of what lies beneath the Earth. The skeleton that they found is astonishing. Dr. Gillette and his team named it Seismosaurus, Earth Shaker. Before the discovery of Seismosaurus, the largest complete skeleton known belonged to Diplodocus. Dr. David Gillette.
Seismosaurus is more than half again as long as Diplodocus, and my best ballpark estimate for length now is 150 feet compared to the 87 feet in Diplodocus.
Seismosaurus probably processed around a ton of plant matter every day. There are still years of work and yards of dinosaur ahead. But already the connection of the bones to the stones, called gastroliths, has been made.
We found about 150 gastroliths in the front part of the body, all having spilled out from the crop, which was in this position. We had one body of gastroliths spill out this way, another spill out back toward where Wilson is working.
This is the first time scientists have seen such a close association of stone with rib bones.
We think that the largest of the gastroliths here give us the minimum diameter for the throat, so that we have a feel for the plumbing that went into the digestive tract. Now, this was an interesting story until we found a problem, and that problem was this gastrolith, which is 4 or 5 times larger than the otherwise largest gastrolith in the set. This one is so large, in fact, that I think there's a good possibility that we can answer the extinction question for one dinosaur in particular, one individual. That's Seismosaurus. This gastrolith is so large that when he swallowed, it got caught in the throat and he finally choked to death.
What kind of plant could survive the attentions of such an awesome eating machine? It had to be something that reproduced quickly with a high survival rate. The fossil record shows that just such new, improved plants first appeared about 130 million years ago at the start of the Cretaceous period. Flowers.
What we're looking at here on the screen is one of the very oldest flowers that we know in the fossil record. This one in particular is 95 million years old.
The early Cretaceous period saw the first great spurt of evolution for flowers. They soon came to dominate all other kinds of plant life. Could there be a connection between this dominance and the rise of the new species of dinosaurs? These new species were low browsers, capable of mowing down acres of vegetation until only bare soil was left. Plants had to evolve forms that could reproduce faster and grow quicker, and this was what flowers are uniquely suited to do. Scientists think that here is an example of co-evolution. One spread, the other fed, and both flourished. At the end of the Jurassic period, these new creatures, with their broad muzzles or sharp beaks, ideal for shearing off the new flowering plants, had taken over from high browsers like Brontosaurus and Stegosaurus. Armed with pincer-like jaws, they were the grim reapers of the quickly spreading low-growth plants of the early Cretaceous. And one of the most successful of these creatures, perhaps the most successful land animal ever, was Iguanodon. At the Royal Institute for Natural Sciences in Brussels, Dr. David Norman is studying them.
This is Iguanodon. It lived during the early Cretaceous, and by any standards, it was a phenomenally abundant animal. It's clearly one of the most abundant that lived at this time in Earth's history. As you see it here, it's not quite restored properly. The vertebral column should be more horizontal. So the animal actually with its head would have been a lower browser. It would have browsed on the lower part of the trees and on the low ferns and ground cover vegetation. But it fed on that in a most unique way. It had in fact developed a technique for processing plant food that no other reptile has ever developed.
Chewing. The Institute for Natural Sciences has restored a group of iguanodons just as they were found in a Belgian mine in the 19th century. No gastroliths were found along with the bones, so they must have processed their food some other way, probably the way we do.
Could Iguanodon chew? And if so, how well? Well, let's look at this skull, just to see what we can learn. At the front end of the jaws, there's a very sharp, roughly edged beak, which was ideal for nipping off pieces of vegetation. Behind that, you have this great big long row of powerful teeth with very steeply worn edges, which are ideal for chipping off and pounding up the plant food that they're eating. More important still than that, perhaps, is the fact that the teeth themselves are actually set in from the sides of the jaws, leaving this very wide recess running up the side of the face here. This was almost certainly covered with a mixture of flesh and muscle, which would have formed a cheek, to prevent the food, once it had been chipped off, from falling from the side of the face. Just behind the teeth, you have this large lump of bone here. And this was the area of attachment for very large muscles that ran down from the side of the head in these spaces here onto the lower jaw to give these animals a very powerful bite. The one vital ingredient that's missing is the ability to really grind the food very effectively between the teeth. And to do that, you need to be like mammals, like ourselves, who are able, because they've got special muscles in their jaws, to be able to move the lower jaw from side to side as they chew. If you look carefully on the side of the skull here, there is in fact a groove which represents a hinge which runs right across the side of the face, past the eye, up to the top of the head at the back here. And this actually allows the cheek region of the skull, up here, to move in and out as the lower jaws moved up and down as the animal chewed. And it was this vital innovation that allowed these dinosaurs to chew their plant food so very effectively. And it was a key to the evolution of this powerful group of plant feeders during the Cretaceous.
In the Cretaceous period, it wasn't only dinosaurs that were developing complex and sophisticated anatomies. So were their contemporaries, pterosaurs. Jeremy Rayner of the University of Bristol, England, studies the flight of pterosaurs, and since they're extinct, his models have to come from somewhere else.
One of the problems of studying pterosaurs is that we know them only from fossil remains, and it's hard to infer with any certainty how they lived, what they did, how they flew. But we can get a good idea about how they flew, what they were able to achieve, by looking at modern birds and bats. From studying birds, we know that flight is very difficult. You can only do it if you're the right size, not too small, not too large. You need to have a large amount of energy available. You need to be able to move the wings in a very controlled manner. And when you can solve all these problems, then you have all the advantages of a flying animal.
The skeletal structure of pterosaurs suggests that their wing mechanics were very much like those of a bird. But to be certain, Rayner has to take a closer look at the aerodynamics of bird flight. Exactly how do birds do it? Wing beat by wing beat, he makes a detailed chart of the subtle corkscrew motions of a gull in mid-flight.
When a bird or a bat flies in air, it has the problem that it has to push air backwards and downwards. Air has to go backwards so that the animal's pushed forwards as a thrusting force. Air has to go down to support the weight. This is film of a slow-flying gull. During the first part of the stroke, in the downstroke, the wings are fully stretched. They're extended and they're a flat aerodynamic surface. During the upstroke, the wings change shape slightly. They stay flat, but the wrist flexes so that the wingtips aren't as far away from the body as they were in the downstroke. By doing this, the animal can support its weight all the time, but still get a forward thrust.
The striking feature of a pterosaur's wing is a very long finger bone, which is extended right out to the wing tip. As it flew, the wing had to change shape, and it did this by a sharp snap of the wrist. We can also see traces of fibers embedded in the wing, making long ridges that acted like birds' feathers and gave the wing aerodynamic structure. Indeed, it had to be so.
If the pterosaur didn't have something of this kind, simply had a membrane or thin elastic wing, it wouldn't be able to support the aerodynamic forces. It simply couldn't fly.
Rayner sees pterosaurs as powerful and efficient flying machines. In fact, by the Cretaceous period, some pterosaurs had achieved a size equivalent to a World War II fighter plane. While pterosaurs were getting bigger in the air, on the ground, dinosaurs were economizing in bulk. Here in the hills of northern Montana, paleontologist Jack Horner is studying the smallest versions of these creatures with the help of a band of volunteers.
So, shall we go to work?
When he was 7 years old, Horner found his first fossil bones on his family's Montana ranch. He's been hooked ever since.
Well, get up here and tell me about it. Well, what is it?
It's a bone.
What kind of a bone?
A tibia.
From what?
A hadrosaur.
Is it from a baby?
No.
No, all right.
From an adult.
So you know it's an adult duck-billed dinosaur,
Mm-hmm.
right?
Yeah.
And did it live here?
Yeah.
Did it die here?
No.
How do you know?
Because if it died here, then you'd see all the rest around it.
That's right.
So it had
So
to
it's
come
been
down.
scattered around, right?
Yeah.
See, you know more than you think you do.
But it's not just professors and students who find bones. Marion Brandvold runs a rock shop in Bynum, Montana. That's why she's out here prospecting, looking for rocks, especially rocks with fossil bones. One day in spring 1978, she came across something she'd never seen before in that area.
I come on down off the hill, and here right close here were some big bones. And I thought, I thought I've walked here before, but I must not have done. So I'm kind of excited about them, but then there was this odd little round place. Now it looks a lot different today. It's not anyway near the same. And on the top were quite a few scattered small bones. Okay, them small bones were different than anything I had seen up in this area.
That same year of 1978, Jack Horner took the summer off from Princeton University to go bone hunting with his friend Bob Michaela. As usual, one of their stops was the rock shop run by Marion Brandvold. They'd heard that Marion needed help identifying some fossil bones.
So we got to looking around, and she had a lot of fossils in there, and a lot of them were misidentified, so we started identifying stuff for her, and she seemed to be real pleased about that.
They asked me if I had any other bones that they could look at, and I said, well, we just found some little bones up on the hill. I said, we don't know just what they are.
I looked at it, and I'm sure I had a surprised look in my face. Turned to Bob, and I said,
Bob, do you know what I'm thinking? Bob says, yeah, I know what you're thinking.
I was really excited. Bob and I were both really excited, but we were in a rock shop, and in rock shops they sell things, and so we were trying really hard to sort of contain our excitement.
And I thought to myself, something's here I got to know about.
And Bob picked up a little dentary with teeth in it, and he looked at it, and his mouth fell open, and he said, "You're right, Jack, this is a baby dinosaur."
And I says, baby dinosaurs? Yes.
We were very excited.
12 years later, every square foot of these Montana hills is the object of intense scientific scrutiny.
When we first came here, there was a good little hill here, and it was on the surface of that hill that Ian had collected the parts of 4 skeletons. And when Bob and I came out, we began carefully excavating into the hill and began running into hundreds of other little bones. So we very carefully prepared down on the top of this hill, just excavating centimeter by centimeter, and we eventually found the remains of 15 baby dinosaurs. And then after examining them and deciding that they were all the same species, we came to a final conclusion that we were looking at a dinosaur nest.
Horner's discoveries opened a window onto the daily lives of dinosaurs. Until then, there was nothing to show that dinosaurs were any different from turtles and frogs, whose approach to their eggs is lay 'em and leave 'em. But here, Horner found evidence of dinosaur nesting and other kinds of social behavior.
Out here we can see a number of the myosaur nests. There's one, the 1978 nest, where the steel spike is. Then about 30 feet this way, the little hill, another one is, and then about 25 feet off to the right, is another one. There's 7 confirmed nests that we found out here, and possibly another one. As we began to find these things, we realized that first of all, the dinosaurs were apparently nesting in colonies, but we also realized that the nests were 25 to 30 feet apart, which is the length of an adult maiasaur. So it appears that the colonies were relatively dense, very much like some bird colonies where the distance between nests is equivalent to the body length of the animal.
On a windswept Montana bluff, the tents of Horner and his team are laid out like giant dinosaur nests. Here, hugging the ground, Horner can begin to deduce what these remains of eggshells and hatchlings really tell us.
In order to find these little baby dinosaurs and eggshell and things like that, you literally have to get down just as close to the ground as you can to see the things. What we have here is a place that we found embryonic dinosaurs, associated eggs, and some we believe are hatchlings. So, looking at dinosaurs that are 16 to 18 inches long, and the pieces, like their vertebrae and their toe bones and things like that, are literally microscopic in size.
Back at the Museum of the Rockies, some of the larger fragments of bone from Montana have been laid out for Horner to examine. They turn out to be the remains of a colony of dinosaurs belonging to a species that had evolved broad, flat bills, like ducks, to take advantage of low-growth vegetation.
This right here is the adult duck-billed dinosaur skull, the dinosaur Maiasaura, and this individual we believe is approximately 4.5 years old. And this is the skull of the individual that is about 3 weeks old.
Here was proof beyond a reasonable doubt that dinosaurs cared for their young. They nested. Putting all his research together, Horner creates a picture of life in a dinosaur nursery.
We can get some really interesting clues about the behavior of dinosaurs when we look at some of the evidence from the nesting grounds. They really couldn't do much moving. They certainly couldn't get up and run around. It's possible that they could stand and walk a little bit, probably very wobbly, but very suggestive that they could not leave the nest and get their own food. And so all of this information together leads to the conclusion that the mother dinosaur, or a parent dinosaur, brought food to the young.
And all this evidence of caretaking and nesting led Horner to name these dinosaurs Maiasaurs, good mother lizards. This social behavior of dinosaurs, caring for their young, nesting in close proximity to each other, suggests the behavior of other social animals such as birds. Horner, who has noticed some striking behavioral similarities between the two, has come to Bowdoin National Wildlife Refuge in Montana with refuge manager Gene Sipe to learn more. Both birds and dinosaurs made nests to protect and incubate the delicate eggs. Further study of the nesting habits of these animals has led to some interesting insights. Horner has evidence which shows that the dinosaurs used the same nesting sites year after year. These finds call to mind pictures of a surprisingly social animal, a reptile that lived and traveled in organized groups.
When we find the eggs, these dinosaurs would actually push their eggs down into sediment, and we can tell that There was at least a bowl-shaped depression that they were in, but we can't tell whether there was a mound.
The eggs just hatched in from the sun,
well, we think they may have covered the eggs with vegetation, so that the rotting of the vegetation would have provided the heat for incubation, and then apparently the babies had just sort of popped the top off the egg after the vegetation was removed, and they climb out.
Horner believes that hatchlings stayed in groups within the colony, just as some ground-nesting birds do today, fed and protected by the parent animal.
So it appears that these dinosaurs probably lived in little pods or groups, the babies, and were probably cared for by a few adults.
And it appears that the adults would also defend them. Species of hadrosaurs probably could have made sounds to threaten predators or alert their young, and may even have banded together to repel threats from meat-eating theropods.
Dinosaurs reached their peak in the late Cretaceous period, as far as we can tell. It's at that point where we have their greatest diversity. It was also a time when we at least see dinosaurs living in large nesting colonies, feeding their young, at least some of them. We also have good evidence that they were communicating with one another, and after nesting, we have very good evidence that they traveled in gigantic herds, or flocks if you want to call them that.
Herds of dinosaurs, flocks of dinosaurs. The idea inspires visions of buffalo in the prairies of the Old West, wildebeest in the Serengeti plains of Africa. Is it possible? Dramatic evidence that it exists here in Provincial Park in Alberta, Canada. Phil Curry of the Royal Tyrrell Museum in Drumheller is prospecting one of the richest dinosaur fossil sites in the world. The late Cretaceous rocks here represent 2 million years of dinosaur history. Over 300 skeletons have been excavated and displayed in museums all over the world. In these rocks, Curry has found 35 separate species of dinosaurs, but a very special story emerges for one of them.
The quarry in the middle of the far cliff is an excavation of a bone bed that we found in the 1970s. Now, the bone bed was accumulating along the bottom of a stream, and the stream was running away from us to the far side of that hill, and it extends for maybe 100 yards or so. In that bone bed, we're finding anywhere up to 60 bones per square meter, and we estimate that in the total bone bed, there's probably 20 or 30,000 bones. Guys, bones today? Nice bird right here. I see you're working your way deeper now anyway. Bones here are for many individuals, and they've all been mixed up. For example, we have individual bones from animals that would have only been probably 3 or 4 feet long, right through to bones from big individuals, animals that could have been as much as 18 feet in length. Almost all of these bones, between 85 and 95%, represent one single species of animal. Many individuals of that animal, an animal called Centrosaurus. Centrosaurus is one of the horned dinosaurs, and you're probably more familiar with its close relative Triceratops. Triceratops is an animal with 2 long horns over the eyes and a very short horn on the nose. Centrosaurus has reversed that. It has 2 short horns over the eyes and a very long horn over the nose. Now, the bones themselves are are fairly fresh. That is, they don't show an awful lot of weathering before they were buried. They do, however, tend to lack the ends.
This bone, for example, has been sheared in a peculiar way. The fracture spirals through the bone instead of breaking straight across as one might expect. This indicates that it was fresh when broken. Putting these clues together, Curry came up with a dramatic story. A herd of 400 to 1,000 centrosaurs trying to cross a river in flood. A herd of African wildebeest trying to do the same provides a glimpse of what may have happened to the centrosaurs.
As individuals, they were probably good swimmers. However, when they tried to cross as a group, they got in each other's way, and many of them would have been pushed underwater, and eventually a lot of them drowned. These drowned animals then floated downstream and would have been deposited on the point bars and the sandbars, or in this case, in an oxbow lake, essentially. And as the flood waters receded, the carcasses were left high and dry on the banks of the river. At that point, small and large carnivorous dinosaurs moved in to basically feast on something that was available to them.
Phil Curry paints an incredible picture. Giant herds of centrosaurs roaming the land. But not all scientists are lucky enough to find an entire herd preserved in the fossil record. We do know, however, that Centrosaurus wasn't alone in its herding behavior. Indeed, its more famous cousin, Triceratops, probably did the same thing. Paleontologist David Fastovsky.
If we saw a live Triceratops, what we'd see is a large animal, maybe the size of a large male bison or possibly even a large rhinoceros. It would be walking around on 4 legs, it would have a relatively short tail, and what it would have is 3 horns, 2 over the eyes and 1 on top of the nose. Triceratops was one of the last dinosaurs in the Age of Dinosaurs. It was also the largest member of its family. If you were to come into the Age of Dinosaurs, what you would see was herds of Triceratops roaming across this countryside. Also, you would have seen things like Tyrannosaurus rex, which would have been quite rare, and some duck-billed dinosaurs, which would have been more common.
In the last 10 million years of the Cretaceous period, dinosaurs like Tyrannosaurus rex and Triceratops were among the 112 groups of dinosaurs that were flourishing. They inhabited the entire world. In this world, colonies of hadrosaurs and maiasaurs made their nests and cared for their hatchlings. The oceans were alive with graceful dolphin-like sea dragons, mosasaurs, ichthyosaurs, plesiosaurs. And above, pterosaurs and small feathered creatures glided through the air. And all over the earth, the plains swarmed with great herds of ceratopsians traveling in search of food, while ever watchful, Tyrannosaurus rex roamed everywhere. And then, in an instant, as geologic time is measured, the entire planet became a graveyard for these apparently indestructible creatures. For 160 million years, dinosaurs had been the most successful land animals ever. Their disappearance 65 million years ago is one of the great mysteries of science. What happened? Was it a change in the Earth's climate, disease, increased volcanic activity, or something altogether different? The latest theory, and one of the most controversial, involves heavenly bodies, global warming, and an oil well that wasn't. If it is true, it will alter many of our ideas about how we, in turn, became masters of the planet.
The families of dinosaur species died out, no new species were formed, and they were gone.
There's an
occasional really bad day, when a huge rock falls out of the sky and makes terrible environmental disturbances.